Hi there, this is Chris. I'm going to follow up on the last video I did, which was talking about a GraphQL API that I'd put together for gc-payscales, Government of Canada Payscales. So basically that was scraping a number of web pages that the government had put up where they had charts and tables of the different rates of pay for different groups and classifications and levels over time, taking all that, formatting it so it's machine readable, and building an API out of it, a GraphQL API. And you can see the API just kind of to the side of the screen. It's available at gc-payscales.herokuapp.com. If you put a / and playground, you can get this nice thing where you can kind of play around and see the API in the schema. But one of the problems with an API is it can be very difficult to understand what to do with it if you're not used to it and if you haven't seen it before. So I decided to put together another quick project that will actually use the API. And this is very simple. Basically, it takes a spreadsheet, it takes the data from a spreadsheet, it queries the GraphQL API, it gets the pay data back, and it creates another spreadsheet with the information that people need to actually do their jobs. So I'm going to show you how that works right now. So on the screen, you can see this is the spreadsheet, this is the test document that we're working on. So we've got 10 fictional people, except for me, I'm mostly real, but all of the other information is fictional. So we've got groups, we've got levels, we've got steps within the levels, and then we've got start dates and end dates. They're all the same, but basically we're looking at January 1st, 2018 to August 1st, 2020. So we're looking at a period of about 2.5 years here. And this could be, for example, a project that starts up, you have a team working on something, they work on something for this period of time, and then eventually the project kind of closes down. So the challenge, if you're managing a team, is figuring out how much are you actually going to spend over the course of a year in salary. Or that's one of the many problems. So that's what we're trying to solve today. So I'm just going to run this and dive right in. So down below you can see this is my terminal. So basically I'm just running the Rust program here. I'm loading up the test.ods notebook right here, and I'm going to output it as an Excel document. So this right now you can see it was querying the API based off what the information that we had put in, and now we're going to open the output, and this is what we get. So basically you can see that there's now 24 rows, and there's multiples for some people in here. In fact, very many multiples. That's because the collective agreements actually changed the rate of pay over periods of time. So if you look at me here in the fictional EC7 group, the first period here is now 2018-01-01 to 2018-06-21, so a period of about 6 months. Within this, I fictionally worked 930 hours or 124 days. This was my hourly rate, my annual salary, and this is the actual amount that I should have made in gross for that period of time. Now, what you'll see is when this period ends, there's actually not even an overlap, a negative overlap, which was necessary just to make sure we were calculating the right days. And anyway, it's a little bit messy, but this is accurate. So no work hours, no work days, but you can see the hourly rate went up a little bit. And then basically on the same day, it went up again. And this was again because the collective agreements are often coming into force retroactively. So some of these changes at pay increment of 0.5% or 1% will happen at the same time. So this basically goes through and tracks all of those over time, shows you kind of what you make over that period or would make. So this is 2018 to 2019, the same period, a full year, and you have the total amount. So and then it does this for the whole team. So basically, you can then kind of go through and just say, I'd like the sum of all of this. And of course, I did not do that quite correctly. So do sum. And then we'll try that. And of course, I forget the equal sign. So equal sum. Then we choose it. And we're still missing one. But basically you have the total there. So this is an example. What could you do with an API? How could you use this? This isn't terribly impressive, but if you think about as a manager, you might be doing this or trying to figure this out or making changes to your budget, maybe once a month. And we have many thousands of managers across the government of Canada. So there's a really high chance that this kind of thing is being done 10,000 times a year, probably many more than that. And then you think about the different ways that it could be done. Going to an API means everyone is querying the same source. Everyone is getting the same information. You can actually build a lot of automation into it, so you can be fairly confident that the numbers are going to be accurate. These ones might not be, but with a bit more work, you can make that happen. What if, for example, different people are maintaining their own spreadsheets? Different people are maintaining their own numbers, updating them at different points of time. You get a huge potential drop in terms of overall accuracy. And that's before you look at some people maybe not even using formulas or automation, but cutting and pasting and manual data entry errors. And this is happening all across a system that has 300,000, well, close to 300,000 employees. So the potential scale and the potential impact of doing things right and using data as a service through an API is pretty staggering. So quick little demo, a little bit of a teaser for what could be done, and thank you very much for watching. All the best.